All right, so today we are going to talk about writing an equation from a graph. So we're going to do it from a graph today, and there's going to be another video on writing it from giving you the zeros without even seeing the graph, okay? So there's a few words I want to talk about. Don't let this freak you out with so many images up here. Okay, so I just want to talk about a few things. We've already talked about a little bit of the graph, but I just want to remind you what we've been talking about, okay? So if you look over here, in this one right here, this guy. All right, roots or zeros. We talked about that. Your roots and your zeros are your x-intercepts. It's where it crosses or touches the x-axis. So these are my roots. These are what I'm going to be using to form my equation, okay? All right, now, these roots, they have something we call multiplicity, okay? And it is just two options here. If the graph crosses at that x-intercept, then it has an odd multiplicity. Your multiplicity is the exponent of your factor. So like right here, x minus 3 squared times x plus 4 to the 4th power, x minus 3 to the 3rd power. These little exponents right here, they are what we call multiplicity. So I could say, I know by looking at those little exponents, so we said odd, so if it is an odd exponent, I know that the graph crosses at positive 3. If it is an even multiplicity, it's going to touch. So at here and here, I know the graph touches, so it touches it. When it touches it, it turns it back around. I know that the graph is going to touch at positive 3, and I know the graph is going to touch at negative 4. Okay? All right. Now, really, when you're writing your equation for this class, okay, we know when we get out to the great world out there that things can change, but for this class right here, if it crosses the x-axis, see how this graph crosses at 0? We're going to say it has a multiplicity of 1. So it's just going to be x minus 0 to the 1st power. Do we have to write that 1? No. So it's just going to be x minus 0, okay? See how this one touches? See how it goes down and it touches it and then it pops it back up? We're going to say that's going to be an even multiplicity, and we're going to say it to be 2. So 9 times out of 10, if it crosses that x-intercept, it's going to be a multiplicity of 1. If it touches that 0, it's going to be a multiplicity of 2. Now, your random little guy is going to be right here. You see how it kind of looks like it crosses and touches? This is a cubic graph, and we would say it would be x minus 0 cubed. Okay, so anytime you see a graph do this, it's going to be a cubed. Okay, so again, I have another little image over here, right here at this one, the black one, okay, the black background. So just again, I'm showing you how it correlates through the equation. See how it crosses at positive 1? Well, it had a multiplicity of 1, which is odd. Crosses means odd. Okay, and see how this graph just touches at 4? That's why I had an even multiplicity of 2. Okay, so if you look down here at this graph right here, it's kind of got a mixture of all 3. All right, so the first thing you do is you get your intercepts. Okay, so I've got an intercept here, here, and here. Now before we do this, I want to remind you how to turn your solutions into factors. Okay, so we have been using the word roots. A root is where we just say x equals. So like when we were doing that delta math and it said what are the solutions, remember solution is also a root. Okay, solution and root mean the same thing. Okay, and we would just say x was 2, x was 3. When I asked you for the x-intercept, that's when we put it in coordinate form. Okay, so solution and root is where we just say x equals. So let's get our roots from this graph. So x equals negative 1, x equals 2, and x equals 4. Okay, those are my roots. Now I want to turn those roots into factors so I can form my equation. Now a long time ago we talked about when there's a minus sign in front of a letter, it doesn't mean minus a, it means opposite a. So it means whatever a is, when you plug it into here, it's going to be opposite. Okay, so x opposite a. So I'm going to turn each one of these roots into a factor. So the first one's going to be x opposite negative 1, which would be x plus 1. 2 is going to be x minus 2 because it's opposite, and then 4 is going to be x minus 4. That's the first thing you do. Step 1. Step 1 is get your roots. Get your roots we'll say step 2 is turn those roots into factors. Okay, and then step 3 is going to be your multiplicities. Okay, now I did teach you that your degree are your humps plus 1. Okay, so if you look, this has 1, 2, 3 humps, so plus 1 would be 4. Okay, so what I want you to know by that is that your multiplicities added up equals your degree. So your multiplicities, so the sum, let's say that. So the sum of your multiplicities equals your degree. Okay? So basically what that means is the sum of all your tiny numbers should equal your humps plus 1. Okay? So all my tiny numbers should equal 1, 2, 3, so 4. So these tiny numbers should equal 4. Okay? Now, let's look. See how this one comes up and it touches and it turns around. It doesn't cross it, it touches it. So at -1, we're going to say has multiplicity of 2 because it touches. It crosses here and it crosses there. So we're going to say that's going to be 1. Check and see if they add up to 4. 2 plus 1 is 3 plus another 1 is 4. So this would be your answer. And, well, technically you don't have to write those little ones. So technically your answer would be x plus 1 squared times x minus 2 times x minus 4. That technically is your answer. Okay? All right, so 3 little steps. Okay? I guess in parentheses we could say adds up 2 degrees or adds up to humps plus 1. Okay? All right, let's do some examples. Some more, all right? So here, it says to put this, so it says write each function in factored and standard forms. We're only going to do factor form because the next unit we're going to get into putting it in standard form, okay? So I don't want to add too much to this when I don't have to. So we're going to save the standard form for the next unit, okay? So we're just going to keep it simple, easy, breezy, light, and we're going to write it in factor form. All right. So now it tells us to beware of our leading coefficient. Okay. Our leading coefficient is just, does your graph end pointing up or is it end pointing down? So it's going to be, where does your graph end? Okay. If it ends pointing up, it's a positive leading coefficient. If it ends pointing down, it's a negative one. We only have to worry about the one pointing down. The one pointing up is going to do nothing to your equation. Okay, so let's do this. All right, so factor form, because we're not even going to worry about this standard form. Okay, so I want to write the factor form. So step 1 is get all your roots. I got a root here, here, and here. So my roots are x equals -4, x equals -1, and x equals 3. Okay. Step 2, put them in factor form. Factor form is where you switch the signs. So it's going to be x plus 4. It's going to be x plus 1. And then it's going to be x minus 3. Okay. So far, so good. Now, multiplicities. All right. Does it cross or does it touch? Cross means a multiplicity of 1. Touch means multiplicity of 2. Just keep it simple like that, okay? You only have to play around with it as if it doesn't add up to your degree, all right? So these all cross, so their multiplicities stay the same. Check your humps. I got 1 hump, 2 hump, plus 1 would be 3. So my degree is 3. So do my little exponents add up to 3? It does. 1 plus 1 plus 1 is 3. So we're good. Last thing you have to handle is, I'm adding 1 extra step to it, is that leading coefficient. Is it positive or is it negative? Well, this guy ends pointing up, so it's a positive leading coefficient, so we don't have to do anything, and guess what? That is your answer. I did more talking than I did working on this one. But isn't that the story for every time I teach you guys? All right, next one. Here we go. Step 1, get those roots. I got a root here, I got a root here, and I got a root there. So x equals -5. X equals -4, And I do believe that's 0. Yeah, that's 0. Okay. Step 2, write them in factor form. That's just write them in opposite. So it's going to be x plus 5, x plus 4, and then x plus 0. Do I need to write x plus 0? I don't. So let's rewrite this by cleaning it up. X plus 5, x plus 4, and I'm going to leave that as x. Now, my OCD freaks out, and I want that x up front. So I'm going to put that x up front. Okay? Is Delta Math going to count it wrong? No. Am I going to count it wrong? No. I just like it to be pretty. The last step, which is the new step, is where does your graph end? Is it end pointing up or is it end pointing down? This one ends pointing down. If it ends pointing down, you've got to have a negative up front. So all I'm going to do is make that x negative. All of these cross, so my multiplicities are fine. And that is your answer. Whoops. Why won't it let me highlight? Okay, it won't let me highlight. I think we've had this problem before in another one. Okay, so this is your answer. Okay, let's do some more. You know I like examples. All right, so next problem. I know you hear I'm cleaning off the desk. It's time to get source over here. All right, scroll down. All right, so we'll get to some that touch. We'll get to some even ones soon. So we're doing the same thing. We're just not going to put it in standard form, okay? So first, get your roots. -2, 2, and 5. So x equals -2, 2, and 5. Okay? Write them in factor form. That just means opposite. X plus 2, x minus 2, and then x minus 5. It crosses at all of my intercepts, so it has a multiplicity of 1. We don't have to write the multiplicity of 1. Check where your graph ends. Does it end pointing up or does it end pointing down? This one ends pointing up, so I don't have to add anything. And guess what? What's your answer? Not too bad. I bet y'all thought when this video started it was going to be so bad. Okay? All right. Next one. Next one, let's do a green, not too bright so you guys can see it. Let's see. That ain't too bad. Okay. Get your x-intercepts, your solutions, your roots. Got 3 of them again. X equals -1, x equals 4, x equals 6. Write them in opposite. X plus 1, x minus 4, x minus 6. They all cross. There are 2 humps, so it should be 3, so I'm good. Now, this one ends pointing down, so that means I need to put a negative out front. And then, after you put that negative out front, you're done. And that's your answer. Okay? All right, let's do some more. I got a few more left to do. Let's get into where it touches and crosses, okay? So, same steps as the last time, okay? So let's do this pretty blue. So get your, oh, don't go nowhere. Okay, get your intercepts. 1, 2, 3. X equals -5, x equals 0, and x equals +3. So when I write this, I've got y equals x plus 5, x plus 0, and x minus 3. They all cross. So it's a multiplicity of 1. Do I have to write x plus 0? No. That just means you're going to have an x out front. So really this is written as x times x plus 5 times x minus 3. It ends pointing up, so my leading coefficient's positive. So once you rewrite it, you are done. Okay? All right. Let's do some that touch, okay? So remember, it's your humps plus 1 that the tiny numbers need to add up to, okay? So when I look at this one, I have 1, 2, 3, 4, 5 humps. So 5 plus 1 would be 6. So my multiplicities need to add up to 6. When I have a bunch of humps, that's really when I count them, okay? So my little exponents need to add up to 6. So let's go to our steps. Get your zeros. Got one here, got one here, and got one here, okay? All right, so I'm actually going, so I got this somewhere, so I'm actually going to, we're just going to say that this is 1, okay, because I don't think you're going to have to deal with any fractions on delta math, and I don't want to add that to this, okay, so just imagine that this crosses at 1, okay, we're going to use our imagination, okay, so my roots are x equals -3, x equals 1, and x equals 3, okay, so let's write it in factored form, x plus 3, x minus 1, and then x minus 3. Now, these all touch, don't they? They do. So remember I told you when they touch, use a multiplicity of 2. So all of these touch, so all of these get a multiplicity of 2. Now, when I add these 2's up, 2 plus 2 is 4, 4 plus 2 is 6. And that's all you needed. You need to make sure they add up to your humps plus 1. So, look at the end. It ends pointing up, so that means it needs to be positive, which it is, and you are done. Okay? All right. 2 more. Now, we'll be making a video that'll help you with your delta math too, so if you need more examples, that'll help you there. Okay? All right. So, laptop's dying. Laptop's dying. I use my laptop too much, don't I? All right, there we go. So, get your roots. So this has got, it's got 1, 2, 3 roots. They all cross, okay? Now I know, because I keep thinking this in my head, I told you that when it does this, it's got a root of, it's got a multiplicity of 3. That's only the case if that is the only 0, okay? And we'll get into the real imaginary, but for right now, let's just forget we talked about that because I don't think I'm going to give you a single one. Okay, and just stick with them being a multiplicity of 1. So my roots are, again, we're going to say that this is at -2. Okay, so we're going to say that's -2 because I don't want to deal with decimals. And then 0, and then 2. Okay, write them in factor form. X plus 2, x plus 0, and x minus 2. Change the x plus 0 to x and put it out front. Check those multiplicities. It all crosses, so it's 1. So we're good. But it ends pointing down, so I need to make that x negative. And then you are done. Okay? Last one. Last one. Last one. Let's end on a pretty... I really want to do this green. Okay, it's good. You guys can see it. So I've got a 0 here, here, and here. Okay, so x equals 0, x equals 2, and x equals 5. Now, so I have 1, 2, 3, plus 1 would be 4. So I need all of them to add up to 4. Okay, so I've got x minus 0, x minus 2, and x minus 5. Now, I don't need that x minus 0, so I'm going to turn that into an x. Okay. Now, it touches at these 2 zeros, so they are fine. But at this 0 where x equals 5, it crosses at these 2 zeros. So these are fine. So it crosses here, so those are good. But it touches here, so I need to have a multiplicity of 2. It ends pointing down, so make that x negative. And that's your answer. Okay? So that's it for this video. I am going to do one on helping you with your delta math. So there'll be 2 videos up there for you guys to watch. All right?